So in the previous video, we've seen that if a sequence is bounded, and it's monotonic, it will eventually converge to some sort of limit. Or if it's always increasing, then it will converge to some sort of limit. So in this video, we're going to make use of it being bounded, of this being bounded, and it's monotonic, to show that this thing here will reach some sort of limit. Okay, so our aim here is to show that it's monotonic, and also to show that it's bounded. So let's start by looking. Well, let's start by trying to understand what's going on here. 2 to the power of n, you can think of it as being 2 times 2 times 2 times 2 times 2 times 2 n times, and then you can think of this as, well, n factorial is really n times n minus 1 times n minus 2 times, well, you can think of it as being 1 times 2 times 3 times 4, blah blah blah. And then if you look at this, you've got one thing divided by another thing. You see, beyond this 2 here, everything, the numerator here will be much smaller than the denominator here, because look, this is bigger than this, this is bigger than this, this is bigger than this, and as n increases, the denominator, the point here is that you've got one thing divided by another thing. As n increases, the denominator is going to be so much bigger than the numerator. So we already have a hunch that this is heading towards 0. But let's pretend we didn't know that. So our aim is to show that this thing will converge. So we're going to try and show that this thing here is monotonic. That it's always well, it seems as if it's always decreasing here. So we're going to try and show that this thing here keeps on decreasing. So the way we do that is this. So we are trying to show that it's decreasing, meaning that the next term. So if you look at your sequence, if something's decreasing, it means that well, imagine this is 6, imagine this is 7 here, and then it's saying the next term, if it's decreasing, the next term will be smaller than the current term. So if you get an plus 1, meaning the next term here, divided by our current situation, an, if this number, well, in our case 6 over 7, you can see that 6 over 7 is smaller than 1. The point is that if you get the next term and divided by the current term, if it's less than or equal to 1, then you know that it's monotonic, because it's always, well, if you have a sequence that keeps on climbing, say, let's imagine this to be 8, and then this here to be 9, and then this is your an plus 1, this is your an. If you get the next term, an plus 1, divided by the current term, meaning if you get 9 divided by 8, you can see that it's above 1, so it's always going to keep on climbing. So to show that this is so hang on. So we are trying to, well, if we get the next term divided by the current term. Hang on. So from here we are going to divide this side. So currently we've got this at the moment. So we're going to divide both sides by this exact same thing. So 2n. Basically, we are trying to get an plus 1, the next term, divided by the current term. This is what we're trying to do here. So this here is our an plus 1. This here is our an here, and then divide this by the exact same thing. So this thing here will eventually be 1, because exact same thing divided by exact same thing. So it's going to be, this side is going to be 1. So the point is that from here we're going to divide top and bottom by 2n over n factorial, 2n over n factorial. So that will then give us this, will take us to here. This would take us to here. So we've got one thing divided by another, and then over on this side you've got this divided by this. That would give you 1. So this thing here would be 1, and then this thing here, you've got one fraction divided by another fraction. So let's just imagine as one fraction times the reciprocal of this. which will be n factorial 2 to the power of n, and I will continue in the next video. Okay.